So for this video, I want to talk about finding information using the periodic table. Now the easiest things to find are the symbol and name of the element. After that, the most important one is the atomic number. So the atomic number is different for every element, and it tells you the number of protons. I'm just going to use P plus to stand for protons. So elements are different from each other in that they all have a different number of protons. We identify the atom by its number of protons. That's what type of element it is. The next number that's on almost every periodic table is going to be the average atomic mass. For lithium here, it's 6.941. This is the average mass of all natural isotopes. So the problem with this is we need to talk about what an isotope is. So basically, an isotope is just going to be a variant of that element with a different number of neutrons. For lithium, we have two possibilities. We have lithium 6 and lithium 7. Now, in nature, lithium 7 is more abundant. That's why our average atomic mass is closer to 7 than it is to 6. So, basically, we can then talk about the difference between these two. When we represent these, we would put a 7 next to Li if we were talking about just lithium 7, and then a 6 in the upper left corner if we were talking about just lithium 6. So real quick, here's a handy dandy little Bohr model atom. Now every lithium is going to have 3 protons in it. So there's my 3 protons. Now, lithium 6 is going to have a total of 6 particles in its nucleus. So we would have 3 neutrons in there. If I had lithium 7, I'd have an extra neutron. So the difference between lithium 6 and lithium 7 is just a neutron. Okay, dokes? So going back then, when we talk about the atomic mass, this is going to be the rounded average. And then using this, we can do the number of neutrons is equal to the atomic mass minus the atomic number. So once again, going back, if I've got lithium 7, so I've got a total of 7 in here. To get the number of neutrons, I would subtract the 3 protons out. And I get 4. 1, 2, 3, 4. Wonderful. Now, I haven't added any electrons to this atom, so I'm going to do that now. Now, the rules are, so we've got our different orbits here. The rules are the first orbit can only hold 2. So there's my 2 electrons on that innermost orbit. Then the third electron would go on the next orbit. This orbit here can hold 8. And that's all we really need to know about. So now that we're talking about electrons, we want to talk about the charge. So protons have pluses because they're positive. The charge, the total charge of an atom, is going to be equal to the protons minus the electrons. So for this one, we've got 1, 2, 3, plus 3, minus 2. Now, if it's an ion, this is an atom with a non-zero charge. Ions are usually going to form in order to get a full valence shell. So right now, if we take a look at valence electrons, the valence electrons are the outermost electron. So valence are the outermost electrons. If I take a look at my lithium atom here, lithium is going to have one valence electron. So the kind of ion that it's going to form is it would give away this one, and then it has two, so it has a full valence shell here that fills up with 2. That would be, well, we name an ion for what kind of charge it has. This is +3, -2, it's a +1 ion. Looking at the valence electrons on the periodic table, the way that it works is group 1 usually form +1. Group 2, +2. 3 through 12 also form +2. Group 13, +3, +4, plus or -4. -3, -2, -1, and then 0. Because these ones are not going to form ions. They're not going to want to get rid of any electrons. Okay? There we go.